So today we will do some theorems based on chi-square distribution. So what is the statement? Theorems on chi-square distribution, or we can say the properties of chi-square distribution. So what is the statement? What is the statement? If x1 is a chi-square variate with n1 degrees of freedom, x2 is a chi-square variate with n2 degrees of freedom, and x1 and x2 are independent chi-square variates, right? Then find the distribution of the variate x1 by x2, or prove that x1 upon x2 is a beta 2 distribution, is a beta distribution of second kind with parameter n1 by 2 and n by 2 variate. So this we want to prove. x1 and x2, they are the independent chi-square variates with n1 and n2 degrees of freedom respectively. Then we have to find the distribution of the variable x1 upon x2. So this is a question related to the transformed variables. Now what is the procedure to find the PDF of the transformed variable? First of all, I will discuss procedure to find the PDF of transformed variables. Right? So what we will do here, the step number 1 is, सबसे पहले हमने क्या लिखना है इसमें? As we have given the PDF, as we have given x1 and x2, they are following the chi-square distribution. So whatever the distribution it is following, first of all, we will write the PDF of that distribution. So step number 1 is write the probability differential of x1 and x2, right? Number 2. Then write the joint probability differential. Joint probability differential. Number 3, of the variables x1 and x2, and how it is written? dp x1 x2. As we have given x1 and x2 are independent, so this will be dp x1 into dp x2. That is the probability differential of x1 and probability differential of x1 and x2. Right? Now the step number 4. What is the step number 4? Then we will make the transformation. Make the transformations. And express x1 and x2 in terms of u and v. Number 5. Then find the Jacobian of transformation, which is equal to curly, whatever you will take a curly x1 by curly u, curly x1 by curly v. So you can write it like that, curly x1 comma x2, or here is u comma. In short, you can. Okay. Number 6 step is now the joint PDF of joint probability differential of transformed variables. This is written as DGUV, which is equal to DP, joint probability differential of x1 and x2 in terms of u and v, into Jacobian of transformation. ये सारा इकट्ठा आएगा into du dv, right? So in order to find the PDF of the transformed variables, if you will express u as x1 by x2, then the next step will be, in order to derive the PDF of u from the joint, you will integrate this, let it be star, integrate star with respect to v. So whatever you will get that joint probability differential of v. So this is a procedure. So according to this procedure, we will prove the theorem. So step number 1. So step number 1 is, as x1 and x2 are independent chi-square variates. X1 and x2 are independent chi-square variates. Are independent chi-square variates with n1 and n2 degrees of freedom. Therefore, the joint probability, differential is given by dp x1 x2, and as the variables are independent, this is equal to the product of their marginal probability differential. So I will put the formula of PDF of x1 and x2 as they are the chi-square variates. So this comes out to be 1 by 2 raised to power ta n1 by 2 e raised to power minus x1 by 2 x1 raised to power n1 by 2 minus 1 into 1 by 2 raised to power n2 by 2 ta n2 by 2 e raised to power minus x2 by 2 x2 raised to power n2 by 2 minus 1. So I will combine the constant, this one and the powers of e. So this is equal to 1 by 2 raised to power n1 plus n2 by 2 ta n1 by 2 ta n2 by 2 e raised to power minus x1 plus x2 by 2 into x1 raised to power n1 by 2 minus 1 into x2 raised to power n2 by 2 minus 1 into dx1 into dx2, and their common value is lying between 0 to infinity. Joint value, जो PDF की जो value है domain की, it is lying between 0 to infinity. Now this was the step number 1. Now step number 2, let us make the transformation. So we will convert, you will write u is equal to x1 by x2 and v is equal to x2. Then we will convert x1 and x2 in terms of u and v. So it implies x1 comes out to be uv and x2 will comes out to be v. So now we will find the Jacobian of transformation. Jacobian, this is the step number 3. Jacobian of transformation. It is given by J, and J will be calculated with the partial differential formula. So when you will calculate it, this will be curly x1 by curly u, curly x1 by curly v, curly x2 by curly u, and curly x2 by curly v. It's determinant. So this comes out to be v, u, 0, 1, and after calculation you will have it will be v. So this is a step number 3. So we have transformed the variables, we have found out Jacobian of transformation. Now we will apply the formula to find the joint PDF of the new transformed variables. This is the step number 4. Thus the joint distribution of random variables u and v is d. This is again the joint probability differential. This is dp in terms of uv into mod of j into du dv. This is the formula that you will apply. So this is equal to 1 by 2 raised to power n1 plus n2 by 2 ta n1 plus n2 by 2. This is in the denominator. This is the denominator part. Now e raised to power. So we have e raised to power x1 plus x2 by 2. So you will put the value. And after putting the value, what you will get? 1 plus u into v divided by 2. Right? x1 is uv raised to power n1 by 2 minus 1. Right? Then we have, what is the value of x2? and x2 we have v raised to power n2 by 2 minus 1 into Jacobian of transformation is v into du dv, right? With the limits 0 and v again lies between 0 to infinity. As x1, अब देखिए अगर u आपके पास है, u is equal to x1 by x2, v we have taken as x2, right? So x2 is lying between 0 to infinity, it means v is also lying between 0 to infinity. ठीक है जी? Then same here, when x1 approaches to 0, u2 also approaches to 0. When x2 approaches to 0, u tends to infinity. U tends to infinity. And if x2 approaches to infinity, u tends to 0. It means the limits of this will be 0 to infinity. So this comes out to be 1 by 2 raised to power n1 plus n2 by 2 tau n1 plus n2 by 2 into e raised to power minus 1 plus u into v divided by 2, right? अब हम u और v को सेपरेट कर लेंगे. So u n1 by 2 minus 1 and v raised to power n1 by 2 plus n2 by 2 minus 2 और एक यहाँ से plus 1 into du dv with the limits 0 v less than infinity, right? So after this, what we want to have? We want to find the PDF of u. ठीक है जी? So in order to find the PDF of u, we have to integrate. So what you will write? Integrate with respect to v over the range 0 to infinity, we get marginal distribution of u as this is integration 0 to infinity. जॉइंट का जब आपने इंटेग्रेट किया विद रिस्पेक्ट टू v, राइट? इसका मतलब जो u वाला सारा पार्ट है वो आपका एज इट इज बाहर आ जाएगा. So this is our constant way, 2 raised to power n1 plus n2 by 2, right? u raised to power कि इंटेग्रेट करना है विद रिस्पेक्ट टू, तो u की सारी जो टर्म्स है वो हमने बाहर निकाल दी. 0 to infinity e raised to power minus 1 plus u, अब इसमें तो कंबाइंड है तो इसमें एज इट इज चलेगा, into v. इसको आप कांस्टेंट लेके चल रहे हैं, ये यहाँ पे कांस्टेंट की वेरिएबल यहाँ पे v है. v raised to power n1 plus n2 by 2 minus 1 into dv. अब यहाँ पे हम डायरेक्टली गामा इंटीग्रल का फॉर्मूला लगाएंगे. This will remain same. u raised to power n1 by 2 minus 1 remains same into du remains same into. So this is star n1 plus n2 by 2 upon 1 plus u upon 2. ठीक है जी, आपने याद रखना है कैसे लेना है. ये टर्म में आएगा, ठीक है? ये जो पावर है ये नीचे आके उसकी ये डिनोमिनेटर में आया, जो v के साथ आपका कोफिशिएंट आ रहा है, और जो v के ऊपर पावर है वो एज इट इज इसकी पावर में कन्वर्ट हो जाएगी. So we have used the standard formula. We didn't evaluate it. We will directly write the formula. So this comes out to be 1 by 2 raised to power n1 plus n2 by 2 ta n1 by 2 ta n2 by 2. It was not the combined one. Basically, I have written the previous code. I have written ta n1 plus n2 by 2. Actually, it is different. So you will rectify it as n1 by 2 into ta n2. ये दो statements अलग-अलग हैं. Plus में हम अपने आप इसको use करके combine करेंगे. So this becomes u raised to power n1 by 2 minus 1 upon, ये सारा डिनोमिनेटर में है, 1 plus u raised to power n1 plus n2 by 2, और टा आपका ऊपर है, टा n1 plus n2 by 2, right? So 1 by 2 raised to power, अब यहाँ पे देखिए आपके पास आ रहा है 1 plus u divided by 2 raised to power same power, ये इसके साथ कैंसिल हो जाएगा, और ये जो है ये बन जाएगा बीटा 1 n1 with the parameter n1 by 2 and n2 by 2. So you are left with u raised to power n1 by 2 minus 1 and 1 plus u raised to power n1 plus n2 by 2 with the limit 0 less than 0 less than u less than infinity. It implies u distribution follows, u means x1 by x2. This follows beta distribution with parameters n1 by 2 and beta distribution of second kind with parameters n1 by 2 and n2 by 2. So therefore, this is a beta distribution of second kind, or you can say that it is beta 2 variate. So this is the theorem number 1. Now we will do theorem number 2. So same x and y are independent, x1 and x2 are independent. Chi-k variates with n1 degrees of freedom. x1 is here, x2 is here. It is also n2 degrees of freedom. Then proof क्या करना है? Then u is equal to x1 upon x1 plus x2 and v is equal to x1 plus x2 are independently distributed. ठीक है जी? And prove that u follows beta distribution of first kind with the parameters n1 by 2 and n2 by 2, and v follows chi-square distribution with n1 plus n2 degrees of freedom. So this is again the question of transform variables to find the PDF of the transform variables. So we will do according to the same procedure. So what is the proof? Again, step number 1. We will start from the joint probability differential. The joint step number 1. The joint probability differential of x1 and x2 is given by, same here, exactly that we have given in the previous screen. That is 1 by, I'm just writing n1 plus n2 by 2, ta n1 by 2. This is ta n2 by 2. Okay, mistakenly I have written here ta n1 plus n2 by 2, so you can rectify. It is ta n1 by 2, ta n2 by 2, e raised to power minus x1 plus x2 by 2, x1 raised to power n by 2 minus 1, x2 raised to power n2 by 2 minus 1 into dx1 dx2 with the limits 0, x1, x2 is less than infinity. Step number 2, transform the variables. Let us transform the variables. ठीक है जी? So u will be taken as x1 upon x1 plus x2 and v is equal to x1 plus x2. So we will convert x1 and x2 in terms of u and v. It implies x1 is equal to u into v and x2 comes out to be 1 minus u into v. So we have converted the x1 and x2 in terms of u and v. Now we will find the limits. Here, as x1 and x2 are chi-square variates, so therefore x1 and x2 have the limits 0 to infinity. It implies, यहाँ पे आप लिख देंगे, it implies 0 less than v less than infinity. So what about u? x1 is less than or equal to x1 plus x2, right? It implies x1. It implies x1 upon x1 plus x2 is less than or equal to 1, right? And x1 अब फ्रंट पे ऊपर है, x1 की मिनिमम वैल्यू कहाँ से शुरू हो रही है? 0 से. It implies 0 and x1 is greater than or equal to 0. It implies 0 is less than or equal to, और ये इस पूरे का नाम क्या है? u is less than less than 1, less than or equal to 1, not infinity. So the v lies between 0 to infinity and u lies between 0 to 1. Now let us find the Jacobian of transformation. This is the step number 3. So Jacobian of transformation, you will calculate u, v into u, then minus v, then 1 minus v. So when you put the value of the Curly's value in this, then you will get this. So after solving this, that comes out to be v. Now DGUV, this is the step number 4. That is joint PDF of u and v. Yeah, joint probability differential of u and v. This is same as it is 1 by 2 raised to power n1 plus n2 by 2 ta n1 by 2 ta n2 by 2 e raised to power. So I will put the values v by 2 into u into v raised to power n1 by 2 minus 1 minus u. I am putting the value of x2 here. The raised to power n2 by 2 minus 1 into Jacobian of transformation into v into du dv. ठीक है जी? So that comes out to be, इसको हम k लिख लेते हैं, बाद में इसको रेक्टिफाई करेंगे. u raised to power सेपरेट कर लेते हैं -1. ठीक है जी? Then सारा u सेपरेट हो जाएगा. 1 minus u raised to power n2 by 2 minus 1. v सेपरेट करेंगे, e raised to power minus v by 2, v raised to power n1 by 2. एक तो देखो v की पावर एक ये आ रही है, एक आ रही है n2, ये -2 से खत्म होके ये आ गया -1. माइनस -1 -2 और एक पावर इसकी बन गया ये this one. ठीक है जी? into du dv. अब इस k को हम दोनों में डिस्ट्रीब्यूट करेंगे क्योंकि we want to prove that u and v are independently distributed. So what we will do, we will introduce star. So I will introduce star n1 by 2, star n2 by 2, u raised to power n1 by 2 minus 1 minus u raised to power n1 plus n2 by 2 minus 1 into du. अब जो इंट्रोड्यूस किया है वो हमें यहाँ पे डिवाइड करना पड़ेगा. 2 हम इधर 2 वाला जो पार्ट है we will take on the side of v into tau of n1 plus n2 by 2. So this is e raised to power minus v by 2, v raised to power n1 plus n2 by 2 minus 1. Right? And into, this is into dv. So joint जो है वो दो अलग अलग मार्जिनल में एक्सप्रेस हो गया. ठीक है जी? You can directly add this is dg1u into dg1v, where dg1u is this one, where dg1v is the marginal differential of v is this. So therefore u and v are independently distributed. And what is the distribution of u? This is a beta distribution of first kind, and this is the chi-square distribution with n1 plus n2 degrees of freedom. So it implies u is a beta distribution of first kind with parameters this, and v follows chi-square distribution with n1 plus n2 degrees of freedom. So hence I am just write down the points how you will remember. If x follows chi-square distribution with n1 degrees of freedom, y follows chi-square distribution with n2 degrees of freedom, then x plus y. One of the additive property of chi-square distribution is that if two random variables are chi-square, their sum is also chi-square. Then the ratio of two chi-square variates is a beta distribution of second kind, and x upon x plus y, it follows beta distribution of first kind, right? Or in this case we have done right now, where you have taken u is equal to x1 plus x2. When you will write the joint differential of this, the limits you will write 0 less than or equal to 1. When you will write the joint differential of v, then you will write the limit 0 less than v less than infinity. So this is the sum of two chi-square variates is a chi-square variate. This is the रेशियो, इसका मतलब रेशियो ऑफ chi-square variate is not a chi-square variate, rather it is a beta distribution of second kind. So that's all about today's